One day, two children were conversing beneath a tree when an apple unexpectedly fell into their hands. Both desired to eat the apple, but there was only one available. One of the children proposed a solution, saying, "I have a method to create another apple based on this one." This leads us to the topic of discussion for today, the Banach-Tarski Paradox. This paradox asserts that it is possible to construct a sphere by dividing and rotating a single sphere, without stretching or adding any new points. Here is the process of building the sphere. We can perceive a sphere as an uncountable infinity of countable infinity sets. Here's a way to generate one of these countable infinity sets. Begin with selecting a starting point on the sphere. Then rotate the sphere by an irrational angle. Retract your steps in the direction of rotation. By doing so, you will obtain a second and third point. And this procedure can be continued to form a path. Since you can enumerate the points along this path, the set points on the path is countable infinity. By choosing infinity many starting points and rotating angles, you end up with an uncountable number of sets. Then we can separate the points into 6 distinct sets. For instance, if the last rotation before reaching a point is an upward rotation, then the point could belong to the up set. Similarly, we have the sets named down, left, right, start, and pole. The start set encompasses all the starting points, while the pole set consists of all the pole points. In total, there will be 6 sets. Now here comes the fantastic part. Let's pick a set, say the left set, and rotate all points in the set to the right. Since the final movement of those points within the left set after the right rotation will cancel out the left rotation, we end up with all the points that can be reached by a previous move from the left, up, down, or start set. Considering our path might contain only starting points, rotating left to reach our final point, the result of rotating right will be the starting point. Without adding any point, just by rotating, we quadruple the size of the set. Hence, we can construct our new sphere using this approach. The Banach-Tarski Paradox was formulated by mathematicians Stefan Banach and Alfred Tarski in 1924. Despite its seemingly nonsensical nature, this paradox has a significant impact on mathematics. It has been proven to be logically equivalent to the axiom of choice. Furthermore, the axiom of choice is demonstrated to be logically equivalent to many statements, including the Cartesian product of any family of non-empty sets is non-empty. Every vector space has a basis. The well-ordering theorem, Tychonoff theorem, and so on. This statement may appear far-reaching, but the well-ordering theorem is logically equivalent to the proof by induction, which we rely on extensively. In other words, the Banach-Tarski paradox is closely intertwined with the fundamental tools of proof that we use every day, making it highly significant in the realm of mathematics.